Hi, folks. Brian Benz here, AI advocate at Microsoft, welcoming you to a JDConf 2026 on-demand session entitled Build Secure, Observable, Production-Ready Agents with a Control Plane. And that long title basically is to describe orchestration of agents or routing of agents. And that's what we're going to talk about today. And I'm going to show you a cool little demo of how you can build your own orchestrator in Java and actually in Python as well. All right, so let's get started. I want to explain actually why you want to do this before we actually get into how you do this. Uh, there's a great article on The Verge about how AT&T is saving tokens and saving costs by 90% by AI orchestration. When you have one agent, it's okay. It's really easy to run that agent and you can scale it. It's great. But you don't need an AI agent to do everything. You're checking tomorrow's weather. You don't need to go out and check with a major model out there, one of our frontier models that has all the knowledge of the universe to find out what the weather is going to be tomorrow. It's a huge misuse of models and the whole infrastructure that builds AI. You can just go out to a service and get that. So you don't need that kind of thing to be integrated with AI at all. And what an orchestrator does is it basically takes a request and decides if AI needs to process this. And if it does, do you need to use a really, really big model or maybe just a lesser model to actually handle the task? That's what routers do. That's what orchestrators do. When you're working, for example, with ChatGPT, Gemini, Claude, all of these, and all the other commercial AI chatbots out there, and even Visual Studio Code with GitHub Copilot, there's a router on top of your large language model. So it doesn't actually interact with the large language model itself. It decides whether or not the large language model needs to be engaged for this particular request. And if it does, which model should be engaged if it's a good infrastructure that you have. So that's what we're going to talk about today. We're going to talk about how you actually orchestrate these things. From prototype to production, multi-agent system. So a single system, which I build all the time, being a developer relations professional, is easy to build, easy to scale, but what do you do when you actually have to have multiple agents talking to systems? And maybe you're talking to legacy systems or a website or something like that as well. Well, now you have to manage security. Maybe the language models that you're working with need GPUs. Most of them do. Those are expensive. So how do you actually coordinate what gets processed by what? And how do you actually develop interagent communication patterns? And how do you keep secure and compliant with everything you're doing? You need observability, you need policy enforcement, you need auditability, you need lifecycle management, and you need that security to make sure that nobody's hacking your system and getting in there in the middle and taking advantage of it. There's all kinds of situations where you can have people literally stealing your tokens and using your AI for their own purposes, unless your system is secured. There's injection, there's misuse, there's rerouting. There's all kinds of things you need to consider. So for the demo I'm going to show you today, Microsoft Foundry Agent Service runs the main agent, and that agent takes an invoice in this case. So the invoice is in a PDF format, and it decides if it's an invoice. Is this an invoice? Okay, if it's an invoice, send it over to my document parsing agent. And the document parsing agent is running on Azure Container Apps, which runs on an NVIDIA GPU. So Microsoft Foundry Agent Service is a scalable agent service. You can go to Microsoft Foundry at ai.azure.com. You can build code, you could build agents, you can add security. There's all kinds of things you can do there. But the main thing for this purpose is it's scalable. So it'll scale up to infinity. If you have a huge load of invoices that you need to process, it will actually handle that, or whatever else your workload is. So it orchestrates the workflow, decides if it's an invoice that we're going to be working with today. So it checks the PDF and says, hey, okay, this is an invoice. I can pass it to the orchestrator agent. So the agent that's running on a GPU, the parsing agent, doesn't actually get engaged unless the orchestrator agent decides that it needs to be. And that's really important to remember. So Azure Container Apps is where the parsing agent runs, and that is a Kubernetes cluster. Think about it like a huge Kubernetes cluster, and you're going to borrow a node from that cluster for a moment, and you're going to use it to parse a document, and then you're going to give that node back to the cluster. That's the idea behind Azure Container Apps. You can scale it up, you can scale it down to 0. It runs well. And it has GPUs, so you can actually run, of course, on CPUs. That's the standard way of running an Azure Container App, but you can also run on GPUs. And that's what we're doing today. So we have an N100, I believe it is, GPU from NVIDIA. And in this case, we're actually using a Nemotron parse model, which is specifically designed by NVIDIA for parsing. And as far as I know, it's the only model out there that's designed specifically and only for parsing. So that's why we're using it. NVIDIA is a good partner of ours as well. They have these great models. I'll show you how you get to build.nvidia.com, and you can actually access a parsing model like that without actually having to deploy anything, which is kind of cool. It's called by the coordinator, and it basically parses the invoice using a GPU accelerator. So it does it relatively quickly compared to what you would have if you were running it on a CPU. So that's basically the coordinator. We have the agent service, which is scalable, calling the Azure Container Apps, which is also scalable, but also on a GPU. The agent service is not on a GPU. It's just on a regular CPU, so it's economical as well. Okay, so what we're going to show you in the demo is what is the next slide: secure agent communication, observability and tracing, policy enforcement, and auditability. So we actually have a way to do that, and I'll describe it in the demo. I'm actually going to start by just showing you the actual demo, and then after that, we'll go into how it actually runs. So we're running a script called deploy demo run on all docs, and basically what it's doing, I'll let it run, and then I'll show you what it actually did. Let's flip over to GitHub, and I'll show you what it's looking at right now. So this is I'll give you the link for this at the end. This is the repo that I've got for this code. There's a Java processing and a Python processing option for you. But in this case, we're looking at an invoice here. This one has an anomaly. In this case, it has a couple anomalies, and it's kind of hard to scan because it's on 2 different pages. So you can see here, the PDF that it's actually scanning is scanning one that's clean. We have one that's actually clean, and one that's not clean. So it's going to check both of those and tell us whether or not they are for processing through our agent. And then here we are. So basically it's gone out and it's got the invoice for us. It's extracted it, and yep. So it tells us, it applies 3 rules: subtotal versus sum of line items, unit price outlier, meaning it's a weird price compared to what that item is usually priced for, and then missing required fields for that. And in this case, it verified using the AI agent at ai.azure.com, and it was running on Microsoft Foundry. It verified it's an invoice, and then it passes that invoice to the parser, which is running on Azure Container Apps. And inside there, it extracted everything successfully. So same items you had, except, took them across the different pages. And it said right here, there's no anomalies detected. And so that's the clean one. So next it's going to start with the second item. It's going to check. There we are. So this one had some anomalies, right? So 2 anomalies detected. There's a price mismatch. So it's $392 as expected. So it took all the line items, added them up, and there's a difference in $20 in the price. Also, premium support is priced at $250, meaning different versus a median price of $42. And the third check was just fine. So you can see here it checks anomalies. So the idea here is you can have an automated system to receive invoices, check them out, see if they're right, and send them back to the vendor if they're not right, or otherwise process them if they're clean and looking good. So the whole system actually runs on Azure. As I mentioned before, let's get back into that. It's inside of this resource group, RG Multi-Agent Demo. And what we've got here is we've got a GPU parse agent, which is that container app. Make this a bit bigger. And we've got a multi-agent hub, which is part of Microsoft Foundry, ai.azure.com. We've got a key vault. The key vault stores all the keys we have. So a key vault is where you can actually store coordinates and keys for endpoints for the models that we're accessing, including the Benz multi-agent OpenAI. That model, as I mentioned before, was GPT-4o. I'll explain why we want to have that in a second. But let's look at how everything fits together here. So if we look here, the GPU parse agent, the container apps environment that it runs on is just a control plane for the container app. And then we have our OpenAI system for accessing, just to check if this is an invoice or not, and decide whether or not it wants to pass it to our GPU agent. And then we have a container registry. That's where you actually place things that actually get deployed out to Azure Container Apps. And then we have a multi-agent hub. This multi-agent hub runs on Microsoft Foundry, ai.azure.com. And basically, it's a multi-agent project. It has a storage account and a key vault. So when you actually process something, while it's being processed, it has to be accessed somewhere by different agents. You can put it in storage. And then the key vault here holds the credentials for the agents, the GPU ACE container app, and everything else basically that we're working with here, including storage. The key vault holds all of these so it can pass information from agent to agent and from service to service and make sure that everything is secure. And I can go in here to my key vault and I can update anything in there, and I don't have to rewrite the system because the system will accommodate whatever endpoint and keys I put in key vault to find things again. So it's a nice way to manage your keys and your credentials for your AI system. Now, I use GPT-4o. I have a lot of models to choose from inside of Microsoft Foundry, 11,288 models today. But I chose GPT-4o because if I compare models up here, I believe, yeah, GPT-4o. It's not the GPT-5 is way better in terms of quality, safety, estimated costs, and throughput, but it just has way more than we need. We don't need this kind of context, 200,000 tokens. We don't need reasoning. We don't need reasoning. We don't need a reasoning summary in this case. Reasoning burns a lot of tokens. So in this case, it's close enough in terms of quality and safety, and estimated cost is really good. And it's just better in this case for the simple tasks that we have for it. You don't need the latest model all the time. In this case, GPT-4o is just fine for determining if the PDF is an invoice, which is all we're doing. We're not asking it to solve any secrets of the universe or anything. And now when we're in here, I can go into the playground and I can actually chat with this model to make sure it's going to be able to do what I need to do, including manually updating the PDF, things like that. Or I can go in here and I could choose Java, and I can choose an SDK. In this case, I'd use the OpenAI SDK because it's the most recent. And I'd use key authentication. And it gives me some code samples here that I can use to work with this model. Then what I can do is I can actually go into my VS Code and I can build a prompt. And I can copy that information into that model if I want to. So in this case, I've actually got in our demo code, I've got some prompts here that you can use. Let's see, where are they? I think they're down here, Java orchestrated prompts. So I actually created several different prompts through iteration, and I went with prompt V3, which basically includes that code that I just showed you. And I asked it to generate a system here that would work with an NVIDIA GPU agent. Now, so that's actually how I chose the GPU in Microsoft Foundry. You can also, when you're ready, you can deploy NVIDIA Nemotron Parse NIM microservice to do this as well. This is inside of Microsoft Foundry. This is one of the models you have to choose from. I could just literally click use this model. It's going to give me some options, and I can deploy it out to my I can deploy it out to a VM as a service or out to my Azure Container Apps as well. But I didn't use that today. I mentioned before buildnvidia.com. So I actually used NVIDIA's service. So if anyone's ever seen GitHub Models, for example, GitHub Models has a similar structure and service as build.nvidia.com, where you can actually just borrow a model to use, in this case, for a demo, without deploying a model. So in this case, Nemotron Parse is one of the options here for models. They have quite a few, but you don't deploy these models like I showed you in Foundry. In Foundry, if I want to use this, I have to go and I have to deploy it. It gives me different object options for projects and where I actually want to deploy it and things like that. I don't have to do that here. All I need here is I go into Nemotron Parse, and it actually gives me the code I need. Now, in this case, it's Python code. And so just so you know, the structure that I built here, this agent running on the GPU parse agent, the container app, is actually running in Python. And that's because I wanted to use that interface with the build.nvidia.com. My orchestrator agent running on AI Foundry runs on Java, and it's just calling things back and forth. So that's a great example of you can use multi-language, multi-process, multi-infrastructure agents whenever you need to, and you can borrow things in a orchestrated agent infrastructure to be practical. So whatever's practical for you. In this case, they only have Python and Shell for interacting with Nemotron Parse. Now, I could use LangChain4j, and I have. In the code sample I'm going to share, I use LangChain4j to access this through REST. But I used Python for this. So I actually built a little Python agent that does the parsing. So a Java orchestrator runs on Microsoft Foundry, and the agent for managing the parsing of the application runs in Python and accesses this Nemotron Parse, the service. And so I just get an API key in this case. It gives you an endpoint down here. You see this here. Integrate API, NVIDIA.com, V1 chat completions. That's going to give it the name that we need of the model here, and then you get an API key, and this API key, you just have to sign up to get that, or sign in if you already have an account, and it'll give you a free API key. It's rate limited, you have a limited amount of tokens that you can use for this, but the cool thing is you can just take this code here, and it will actually work with the existing deployed large language model at build.nvidia.com. So as part of your testing and running, you could do that. Now, if I need to later, I could deploy this model over here on the Foundry and have the same functionality, but I have 100% control of it, no rate limits, security, everything like that. So in this case, I'm sharing the parsed information that the parser builds in the GPU. So it actually takes that information, passes it to the parse model here, and then verifies that everything is done. It does this through these things called bounding boxes, which I don't have time to get into in this session. Yeah, so that's basically how that works. And I use, once again, ai.azure.com. I use the agent for orchestrating the application, and that runs in Java, and it calls a GPU parse agent, and that runs in Python, and that calls build.nvidia.com to take the parsed information that was done with the benefit of a GPU, check it to make sure it does everything it's supposed to do, pass it back to the orchestrator if there's an error or if it's okay, and let the orchestrator handle it from there. So that's basically how the whole thing works. All right, so aka.ms/Microsoft NVIDIA demo is where the repo is that I showed you. Feel free to check that out. Ask me any questions. I'm on the socials at Benz, also on GitHub at Benz. And please link with me on LinkedIn if you're interested. My name is Brian Benz. I'm a principal AI advocate at Microsoft, and this was Build Secure, Observable, Production-Ready Agents with a Control Plane. Thanks for joining.